Welcome to Hartman Math. This is lesson 3.7, solving quadratic equations by square roots. So previously in 3.5, we had solved quadratic equations by factoring. So this is going to be our second method for solving quadratic equations. So example number 1, x squared, there's the quadratic part, plus 2 is equal to 27. If we're going to solve by square roots, we want to isolate the x squared. So we're going to go minus 2 both sides. Next, we're going to square root both sides. But keep in mind, if we're thinking of figuring out what are all the different x's that make this true. So what are all the different numbers that you could square and get 25? Well, 5 is definitely one of them. But there's also negative 5. If we square negative 5 times negative 5 is also 25. So when we square root both sides, we're going to get a positive and a negative. So there's where it says, remember the plus minus. So we say x equals plus or minus the square root of 25. We know that the square root of 25, being that 25 is a perfect square, the square root of 25 is 5. So our final answer, x equals plus or minus 5, meaning there are two solutions, x equals positive 5 and x equals negative 5. So when you square root both sides, remember the plus minus. Don't save it for the answer. As soon as you do it, that's where it appears. Example number 2, solve. Again, we want to get the x squared by itself, so we're going to need to get rid of the 2. So to undo the multiplication, we're going to divide both sides by 2. Now we're ready to square root both sides. X equals plus or minus the square root of 8. That might be the answer. We do have to see if we can simplify it. Now, 8 is not a perfect square, so it's not going to turn out to be a whole number or an integer. It's going to be irrational. But we do want to see if we can break it down like we were talking about in a previous lesson. So break it up, looking for a perfect square that evenly divides into 8, and 4 is the one. So we're going to break this up into plus or minus the square root of 4 times the square root of 2. The square root of 4 is 2. So we're going to change that to just be plain old 2. Final answer, x equals plus or minus 2 square root 2. Go ahead and pause the video here as you solve this equation. Step 1, we're going to undo the addition. Step 2, we're going to undo the multiplication. Now we're ready to square root both sides. 33 can be broken down, but I don't think there's a perfect square that goes into 33. There's 3 and 11, but neither of those is a perfect square, so just leave it as is. There's our final answer. And example number 3. We need to get rid of the 3. So let's undo the 3. Let's divide both sides by 3. Unfortunately, it does not divide evenly into the 25, so we're going to have to keep it as a fraction. Now we're ready to square root both sides, plus or minus the square root of the fraction. Now remember, in a previous lesson, we learned how to simplify square roots of a fraction. We're going to break it up, square root top, square root bottom, square root numerator, square root denominator. Well, this one I think we know what it is. What is the square root of 25? That one just becomes 5. Now we are going to need to fix the denominator. So to fix the denominator, we'll multiply the denominator by the square root of 3. And if we're going to do it on the bottom, we should do it on top as well. So we're going to fix the denominator, multiply top and bottom by root 3. We're going to get a final answer. We can't multiply these. That's not in a root. That one is. So plus or minus 5 root 3 over, multiply these together, and you get a denominator of 3. Final answer. Example number 4. It's a little bit different about this one is the parentheses. We're not going to try to get rid of the parentheses initially. we are going to undo the addition, undo the multiplication. So we've isolated what's being squared. We're going to leave this alone and say, I now want to get rid of the exponent. I cannot distribute an exponent over addition. But I can get rid of the exponent. To undo squaring, we'll do square root both sides. If I square root the left, I'm going to get x plus 5. If I square root the right, plus or minus, square root of 20. Now we've got a couple things to do. I want to get the x by itself. So we're going to subtract 5. I prefer when I add or subtract to do that in front of the plus minus. If I do it back here, I think it's going to somehow maybe work with the 20 or whatever. It's not. So I'm going to put it in front of the plus minus by subtracting 5. And I want to break this down. I do know there's a perfect square that goes into 20. And that's 4. So I'm going to subtract 5 both sides. I'm going to break up the root 20. This is 2. And that's really as far as I can go. Because if it was just negative 5 plus or minus 2, I would do negative 5 plus 2, get an answer. Negative 5 minus 2, get an answer, because those are like terms. But this isn't just a 2, it's a 2 root 5. And this is not a root 5. So these are not like terms. That means that's as far as we can go. All right, you try this one. Pause here as you work through. All right, let's undo the addition. Now the expression that's being squared is isolated, so now we're going to square root both sides. Don't forget the plus minus. We'll add 7 to both sides. Again, I like to do that in front of the plus minus. And we're going to break this down. Now, there are multiple perfect squares that are factors of the 72. You want the biggest. That's going to be 36. This is going to become 6. We will then divide by 2. Division distribute, so it has to be all of this divided by 2. So I'm going to have a long fraction bar. The whole thing up there divided by 2. And that's really as far as we can go. Okay. I wouldn't divide the 2 into the 6 because it would have to distribute and also do it there, and it doesn't really go into the 7. So I'm good leaving it like this. That's it for today. See you next time.